Today we are learning a lesson on 6.5, proving triangles similar by side, 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 and side, angle, side. Now, as I mentioned in the previous lesson, angle is going to be our go-to, especially in proofs. So fortunately, this says prove, but for the most part, this is more of an algebraic method because we need numbers to see the sides are similar, or we already need other triangles similar in order to get to this point. So starting off, if all three sides of one triangle are proportional to all three sides of another, moving, we've got either triangle DEF or GHJ is similar to ABC. Which one is it? Oh, is either. Sorry, reading directions. So let's check it out. So order matters. So I need to compare AB to DE. So fortunately, this one's color coded, by the way. So 8 to 6, does that equal my next two? EF to BC, which is green. Right? So there's 8 to 6 equal 12 to 9. Now notice, I listed this triangle first, so you got to keep consistent. We're going triangle 1 to triangle 2. Otherwise, you could clearly see it would be wrong if I flip-flop. So far, 4/3 equals 4/3, right? So far, we're good. And again, for those who aren't great at simplifying fractions, you can cross multiply. 72 equals 72, so those are equal. Find the last one. Now we got 16 over 9. Does that equal 2/3? Or sorry, 4/3? It does not, right? Cross multiply, 36 does not equal 48. So it's not this one. So it's most likely the next one. But double check. We've got 8. Oh, I grouped that one up. So pumping the brakes, I grouped that one up because it's not 9. We already did 9. It's 12. 12 to 16 to 12, which is equal, right? 48 equals 48. So caught my mistake before I went too far. The next one's even worse. Right? 8 to 8 does not equal 12 to 10. So right away, that one didn't work. So it is, this one is the right one. So it is similar to triangle DEF. And again, a note there is make sure you double check the next one. If you check the next one and then just assume it was the right answer based on how I made my mistakes, you'd all of a sudden be like, wait a second, 1 doesn't equal 10/12 or 12/10, however way you wrote it. So, yeah, you get the mistake pretty early in the next one. Moving on, find the value that makes them similar. So, notice we've got two sets of x's here. We don't need to use both of them. Most of the time, you need both of them to make sure it works. We don't. Okay? So, pick which one looks easier. In my opinion, x minus 1 looks easier. And what side is involved with that, right? BC is going to be connected to EF. So, x minus 1, that's what I'm talking about for those who are like, what? Why did you choose those? So, again, corresponding, they need to matter. And then EF of 18. So far, x minus 1 of 18 needs to equal. I'm going to pick the one that has numbers, which is AB and DE. Right? Those are the first two letters. So AB was 4, DE was 12. And now I'm ready to cross multiply and divide. Right? So proportion solving, 12 times x minus 1 equals 4 times 18. And you can also find rules. So just so you know, if I were to simplify times 6, x minus 1 equals 6. Right? But a couple different ways to solve. So dividing by 12, we got 4 goes into 12 3 times, 3 goes into 18, 6. So x minus 1 is still equal to 6. Plus 1 to both sides, x equals 7. If we plug it in over here, it would also work. 7 plus 1, 8 times 3, that side 24. 7 minus 1 is 6, so 4, 6, 8, 12, 18, 24. And those work, right? Right, if you look at that at the end, those all equal 1/3. Next, show the triangle similar, write a similarity statement, and a scale factor. So this one we see variables. So kind of looks like, right, we're going this way to this way. But generally, if it's close enough and you can't tell, go with the shortest, right? 4 is the smallest number here. I'm going to do 4x to 3x, which conveniently enough is 4/3, right? The x's drop off. Does that equal the next step? 6x to 4.5x. Right, notice the x's drop off again, cross multiplying. 18 equals 18, so that one does work. Next, does that equal 8y to 6y? Y's drop off equals 4/3, and yep, those work. So yes, our scale factor is that 4/3, by the way. So it sounded like an extra step, but as long as we were going A to B, we didn't have to mess around with our answers. Similarity is just going to be triangle A similar to triangle B. Right? I didn't give you letters to really do that with. Normally each vertex would have a letter. So you won't see that often where they're just triangles labeled as triangle 1 and 2 for A and B. Next, show triangles are similar, write a similarity statement and a scale factor. If you love distance formula, this is your problem. If you don't, you may want to skip this one. So I need to find the distance of AC, AB, BC, and then I need to check that the similarity is the same with DE, EF, and DF. And again, this is show they're similar, so they will be similar. So again, we're going up 3 over 1, 2, 3, 4, 5, 6. So again, AC, I'm going to put my answer there. Square root is 3 squared plus 6 squared. 9 plus 36 is 45. So I got square root of 45, which we can simplify. Right? 45 is a perfect square, 9 times 5. And so the square root of 9 is 3, so you can take a 3 out, and this will actually be 3 square root of 5. If you need a refresher on how to do that, please let me know. I'm not going to teach a whole lesson on that in the lesson, but if you got questions on that, feel free to ask during a free lesson. Next, AB, we're going down. Got to make that right triangle here. So down 1, 2, 3, 4, 5, 6. Over 3, 4, 5, 6, 7, 8, 9. So 6 and 9. Square root of 6 squared plus 9 squared. Calculator doesn't hurt here. 81 plus 36 is, I think I got 117. Yep. So the 117 is 9 times 13. So what do you know? You get a 3 out again. 3 squared of 13. And then the last side. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 3. So square root of 9 squared plus 3 squared. 81 plus 9 is 90. That one's 9 times 10. We're allowed space down there, but that's going to be 3 squared of 10. Going to the other side, we're doing the same thing. DE, EF, DF. Just counting, we got 2 by 2, 4, 6. So 2 squared plus 6 squared. Under square root, 4 plus 36 is 40. And that's 4 times 10 would be 2 squared of 10, right? And that was DE. Next, EF, to 4 by 2, 16. 4 squared plus 2 squared is 16 plus 4 is 20. Square root of 20 is 4 times 5. So 2 root 5 for EF. And the last one's probably going to be 2 root 13. Let's calculate it out. 2, 4, 6. 2, 4. 4 squared plus 6 squared, 36. Plus 16 is 52, giving you 2 root 13. And now, it's a real quick comparison because the one's with 5 compared to the one with 5. So 3 root 5 over 2 root 5 gives you 3 to 2. Same thing, right? So we check that one off. Same thing with the root 13. 3 root 13 over 2 root 13 is 3 to 2. Right? The root 13 cancel out. And so, right, what's it ask for? Write a similarity statement. But so far we got scale factor, it's 3 to 2. We'll do the last one just for those who are like, we only did 2 of them. Yep, true, we only did 2. And then we got 3 root 10 over 2 root 10, giving you 3 to 10. 3 to 2, sorry. 3 to 10, what? So there's our scale factor, and then we just kind of have to connect our lines. Which ones were similar, right? AC was similar to EF. Next one, AB was similar to DF. So we're going to go ACB similar to EFD. Go out of order what we're doing, but figuring out which two so we can kind of get the three letters in order that is correct. Moving on. Which of the three are similar? Write a similarity statement. Now, we do have letters here this time. Got to go with smallest to largest, right? Because otherwise, how can you tell? I mean, you can kind of see it could be flipped, but I'm going to do 20 to 24. Compare that to the next smallest, 24 to 30. And right away, I'm not, the best of my 24 squared, maybe it's 576, I don't know. And 0 times 0 is 0, 4 times 4 is 16. I already know they're not going to equal just based on the ones position. So it's not these two. But we got to move on and try, maybe we'll try this one and the last one. Right? Same method, shortest 20 to shortest 30. So 20 to 30, that was a nice 2/3. Now I'm going to the next side. Right, medium, so 24 to 36. Is that equal? 72, 72. Yep, that one's also 2/3. And then the last one, 26 to 39. This is times 13, so I know they're equal. And that is my ones, right? Triangle, I went LMN, shortest to longest, similar to triangle, shortest to longest, YZX. Right. So shortest to longest and shortest to longest. Those who are wondering where that came from. Also, notice it took me one not working to be done with that triangle. I didn't go on and see if I goofed up my order. Shortest should be similar to the shortest side. Otherwise, they're not going to be similar. Shortest side of a triangle, RST, is 12 units long. Find the other side of length of this triangle. So we've got two triangles similar, and we don't see the third triangle and this other triangle. But basically, they're saying this triangle is similar, and you've got 12 here. Find the other lengths. So what we're doing is 24 to 12 gives us a 2-to-1 scale factor between the seen triangle and this is the unseen. Right? What are the other two sides? You set that equal to 30 over we don't know. Cross multiply and divide. 2x is 30. So that second side is 15. Right? And then the third side, 2-to-1, equals 33 over the last side. 2y is 33. Y is 16 and a half. So what are the other sides? 15 and 16 and a half. On my other two sides. All right. Find the scale factor with the given. Find the others using scale factor. Next, side angle side, so that we have an angle congruent between two similar / proportional sides, then the triangles are similar. Easy enough. This time we can use some vertical angles, like such. So in this example, vertical, stated. And now, shortest to shortest, what's smaller, 7.5y or 2.5x? I would just go with, right, the x to x. And we're checking if that's similar with 3y to 7.5y. Why can't I put my order up? Since this one was first, this triangle is first in my order. Also, it is asking for the similarity scale factor from A to B. So we got 1 over 2.5, is that equal 3 over 7.5? Cross multiply it, and you get 7.5. So those are indeed equal. They're both equal to 2 over 5. And so there's my scale factor. You wouldn't use decimal and that, right? So basically, I multiply this by 2 to get nice numbers. You could also multiply this by 2 to get 6/15 and then simplify. The 2 to 5 is my scale factor. Similarity statement is going to be, I'm just going to go, we did side 1, angle 1, side 2. Side 1, angle 1, side 2. So I got triangle STR like star, similar to triangle BTW, like nowhere we got that. Next, What method would you use to show? We've got two angles, sorry, a side and two sides and an angle. You'd show side, angle, side. Right. Doesn't even ask us to solve it. We've got two sides, can't be side, side, side. I don't have anything besides a vertical angle, gotta be side, angle, side. The last one, the challenge one, I'm not gonna do this on here. If you like the challenge one, go ahead, pause this video and work on it. But basically you have to do 2 or 3 different similar triangles to get angles and pieces of BKD, and this one to be similar to each other just from the outside lines being parallel. And that's the last similarity thing we've got here. Angle, angle works, side, 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 angle, side. And clearly, based on the number of proofs we did today, that angle, angles are quick and easy, show that the triangle's similar. From there, you can get some proportions to help you out for that challenge. That wraps up today's lesson. As always, email me if you got any questions.